in this example, we want to graph the polynomial function h of x equals x to the fifth minus 20x cubed plus 64x. And we're going to do this by using our 6-step process. So we're going to begin by looking at the end behavior. Then we're going to find the zeros and multiplicity, which will give us the x-intercepts. Then we're going to look at our table of signs, which is going to tell us if our function values are positive or negative for each interval created by the x-intercepts. Then we're going to find the y-intercept, and then if necessary we'll find some additional points to get our rough sketch, and then we'll check it. So to find the end behavior, we look at our polynomial function. In this case we have a degree of 5, and the leading coefficient is understood to be 1. So we have an odd degree and a positive leading coefficient. So that means our end behavior is going to be down on the left and up on the right. Now, to find the zero and the multiplicity, we're going to set our function equal to 0. So we're going to look at x to the fifth minus 20x cubed plus 64x. We're going to set that equal to 0 and solve. Now to solve this, first of all, notice that each term has a common factor of x, so we can factor out x. If we factor x out of x to the fifth, that leaves x to the fourth, minus, if we factor x out of 20x cubed, that's going to leave 20x squared, and again that's minus. If we factor x out of 64x, that will be plus 64. So we have x to the fourth minus 20x squared plus 64, which we can factor. So looking at the 64, we want to find two numbers that multiply together to be 64 that add together to be negative 20. And so that will be negative 16 and negative 4. So this factors into x squared minus 16 times x squared minus 4. And then x squared minus 16 is a difference of squares, so that will factor, and x squared minus 4 is a difference of squares, so that will also factor. And so x squared minus 16 factors into x plus 4, x minus 4, and x squared minus 4 factors into x plus 2, x minus 2. So we have 5 factors multiplied together equaling 0, which means x equals 0, or x plus 4 equals 0, or x minus 4 equals 0, or x plus 2 equals 0, or x minus 2 equals 0. So x equals 0, or if x plus 4 equals 0, then x equals negative 4. If x minus 4 equals 0, then x equals positive 4. If x plus 2 equals 0, then x equals negative 2. And if x minus 2 equals 0, then x equals positive 2. So in this case we have 5 zeros, and if I put those in order, they're going to be negative 4, negative 2, 0, 2, and 4. And so that also means then each of these is the x-coordinate of our x-intercepts. So we're going to have x-intercepts of negative 4, 0, negative 2, 0, 0, 0, 2, 0, and 4, 0. So we're going to use those values to find our intervals for our table of signs. So again, our zeros, we had 5 of them, are negative 4, negative 2, 0, 2, and 4. So those 5 zeros are going to create 6 intervals for us. So we're going to be looking at negative infinity to negative 4. We're going to be looking at negative 4 to negative 2, negative 2 to 0, 0 to positive 2, 2 to 4, and finally 4 to infinity. So again, this is making 6 different intervals for us. So if we choose a test value for the interval negative infinity to negative 4, we can choose any value between negative infinity and negative 4. So, for example, negative 5 would be a good number in that interval. So we're going to find h of negative 5. Now remember, our function is h of x equals x to the 5th power minus 20x cubed plus 64x. So if I find h of negative 5, that is going to be negative 5 to the 5th power minus 20 times negative 5 cubed plus 64 times negative 5. Now, negative 5 to the 5th power is negative 3,125. Negative 5 cubed is negative 125. And negative 125 times the negative 20 is positive 2,500, or plus 2,500. And 64 times negative 5 is negative 320, or minus 320. So negative 3,125 plus 2,500 minus 320 is negative 945. So h of negative 5 is negative 945. Again, we don't really care so much about the specific value for our purpose at the moment, but what we care about is that it's negative, which means for that interval, our graph is going to be below the x-axis. Now we're going to do the same for the interval negative 4 to negative 2. We're going to choose a test value in that interval, and so negative 3 would be a good test value. So we need to find h of negative 3. So h of negative 3 is going to be negative 3 to the 5th power minus 20 times negative 3 cubed plus 64 times negative 3. Negative 3 to the 5th power is negative 243. Negative 3 cubed is negative 27, and negative 27 times negative 20 is 540. 64 times negative 3 is negative 192. So we have negative 243 plus 540 minus 192, and that is 105. So h of negative 3 is 105, which is positive, and so that means for that interval, our graph is going to be above the x-axis. Next, look at our interval from negative 2 to 0. So a nice number between negative 2 and 0 is negative 1. So we need to find h of negative 1. H of negative 1 is going to be negative 1 to the 5th power minus 20 times negative 1 cubed plus 64 times negative 1. Negative 1 to the 5th power is negative 1. Negative 1 cubed is negative 1 times negative 20 is going to be plus 20. And 64 times negative 1 is minus 64. And negative 1 plus 20 minus 64 is going to be negative 45. So h of negative 1 is negative 45, which is negative, which means we will be below the x-axis on that interval. Continuing, looking at the interval 0 to 2, a good test value would be 1. So if we find h of 1, that's going to be 1 to the 5th power minus 20 times 1 cubed plus 64 times 1. 1 to the 5th power is 1. 1 cubed is 1 times minus 20 is going to be minus 20. 64 times 1 is 64, so plus 64. 1 minus 20 plus 64 is going to be positive 45. So h of 1 is positive 45. The main thing that we care about is that it's positive, and that means we're going to be above the x-axis on that interval. Looking at the interval 2 to 4, We can choose a test value of 3 and find h of 3. So we're going to have 3 to the 5th power minus 20 times 3 cubed plus 64 times 3. 3 to the 5th power is 243. 3 cubed is 27. 27 times 20 is 540, and it's going to be minus. So minus 540. And 64 times 3 is 192, so we have plus 192. 243 minus 540 plus 192 is going to be negative 105. So h of 3 equals negative 105, which is negative, which means we are going to be below the x-axis on that interval. In other words, the graph is going to be below the x-axis when x is between 2 and 4. Finally, our last interval, from 4 to infinity, we can choose a test value of, say, 5. So we need to find h of 5. h of 5 is going to be 5 to the 5th power minus 20 times 5 cubed plus 64 times 5. 5 to the 5th power is 3,125. 5 cubed is 125 times 20 is going to be 2,500, but it's going to be minus. So minus 2,500. And then 65 times 5 is, it should be 64. 64 times 5 is going to be plus 320. So 3,125 minus 2,500 plus 320 will be positive 945. Main thing is that's positive, which means we are going to be above the x-axis. So now we're ready to move on to step 4. So in step 4, we want to find the y-intercept. Now remember, our function is h of x equals x to the 5th power minus 20x cubed plus 64x. So to find the y-intercept, we're going to find h of 0, which will be 0 to the 5th power minus 20 times 0 cubed plus 64 times 0. And so that's going to be 0. Our y-intercept is the point 0, 0, which is going to be located right here. So now we're ready to make our rough sketch. In step 2, we found that the zeros, and thus the x-intercepts, are occurring at negative 4, negative 2, 0, 2, and 4. So if here is negative 1, negative 2, negative 3, negative 4, negative 5, and 1, 2, 3, 4, 5. We know we have x-intercepts at negative 4, at negative 2, at 0, at 2, and at 4. We know that because of the zeros of the function, which means negative 4, 0 is an x-intercept of the graph, negative 2, 0 is an x-intercept of the graph, 0, 0 is an x-intercept of the graph, and that's also the y-intercept of the graph. 2, 0 is an x-intercept of the graph, and 4, 0 is an x-intercept of the graph. Now in step 3, we found that when we were on the interval from negative infinity to negative 5, that we would be below the x-axis. So over here the graph's going to be below the x-axis. We found that when we are between negative 4 and negative 2, the graph will be above the x-axis. And then from negative 2 to 0, we're below. From 0 to 2, we're above. From 2 to 4, we're below. And from 4 to the right, we are above. So for that to happen, our graph has to go up and back down to be above on that interval. Then it's going to go below, and somehow it's going to come back up to be below on that interval. Then it's going to go back up and be above on that interval, and then it's going to be below on that interval, and then it's going to be up from then on. So roughly, our graph is going to look something like this. Now we can check this by looking at the graph on the graphing calculator. So if I bring in my graphing calculator, I've already entered the equation into the graphing calculator. If I try a zoom 6, I don't think I'm going to get a very good looking graph, and I don't. I can see the x-intercepts, but I need to see much higher and much lower. So if I expand my window, let's say maybe we'll go negative 200 to positive 200, and maybe a scale of 25. And so if I do that, I get a much better looking graph, and I can see that we have our x-intercepts, which are at negative 4, at negative 2, at 0, at 2, and at 4. We are below the x-axis when we are to the left of negative 4. We are above the x-axis when we're between negative 4 and negative 2. We are below the x-axis between negative 2 and 0. We're above the x-axis between 0 and 2. We're below the x-axis when we're between 2 and 4. And when we're to the right of 4, we are above the x-axis. So our analysis proves exactly right.